We know the motion is relative. We know we have to establish the origin, the location of an observer, and everything's supposed to be measured relative to that observer, but an observer can be anywhere in the world. So what is happening when one object travels relative to another object that travels relative to another object? I've got a visualization. So this piece of paper represents the airplane, which can fly relative to the ground. And this motorized cart represents the passenger. Well, right now the passenger was walking. If I place the passenger in a plane, which is grounded, not moving, Boeing 737 MAX, the displacement of the passenger relative to the plane will be equal to the displacement of the passenger relative to the ground. Nothing new here. So now I'm going to make the plane move with the passenger inside it moving. So the passenger still was moving relative to the plane in the same direction, traveled same distance. So this is still displacement of the passenger relative to the plane, still exactly the same. But now the displacement of this passenger relative to the ground is different. Now it's this. So probably you should look here. You cannot see it there. So if I want to measure distance traveled by the passenger relative to the ground, I can use a ruler. Technically, stoi. What should we do? This is start. This is finish. It was traveling that way. There is an algebraical relationship which describes the relationship between these vectors. This is what we can write. Bless you. The displacement of the passenger relative to the ground, this short arrow, is equal to the displacement of the passenger relative to the airplane. And now a tail to a head rule means plus the displacement of the plane, airplane, big P, relative to the ground. For passenger relative to the plane. A plane relative to the ground. And that will be passenger relative to the ground. In the end, it travels with the plane in the east direction. The equation that relates them as vectors looks like this. The displacement of the passenger relative to the ground is equal to the displacement of the passenger relative to the plane plus the displacement of the plane relative to the ground. When we use vectors, we add them. And if this is the x-axis, magnitude of the displacement of the passenger relative to the ground, it should be positive, should be equal to difference between magnitudes.